When you see circuit problems like this, they are usually not as difficult as it appears. Let us go through this one and see what it is. It says, what is the current I flowing in the circuit when A, the key is open, B, the key is closed? In this circuit, there is a current I flowing through, and our target is to find the current I when this key is basically a switch, when the key is open in the first instance as it is, and B part of the question is when the key is closed. In other words, when you close up this opening for there to be a continuous path for current to flow, what will be the current I? That is the question. This question, the source or the potential difference of this circuit is 9 volts and the current I is flowing. We want to see what happens when the key is open. First, when the key is open. Now let's look at the circuit. When this key is open, as it is now, what do you think will happen to this current? It flows from the source, the 9-volt source, gets to this point. Part of the current flows through this 4 ohms resistor, while the other part comes this way. When it gets to this point, it finds this place open, and the current can no longer continue to flow because of this open circuit here, this key that is open. Because the current can no longer come this way, it therefore means that all the current flowing through will go through this point and then back in return to the source. So the circuit or the current only sees this part of the circuit like this. This is what the current is saying. The current is seeing a 4 ohms resistor in series with a 2 ohms resistor. It no longer sees this 8 ohm resistor because there is no continuous path for it to flow. So we are just going to be analyzing this section of the circuit, and you can see that the current flows through the 4 ohm resistor and the same current flows through the 2 ohms resistor. It therefore means that these 4 and 2 ohm resistors are in series. So the A part of the question, when the key is open, 4 ohms is in series with 2 ohms. 4 in series with 2. And because they are in series, the total resistance R will be the sum of the two resistors or resistances, 4 plus 2, and that is 6 ohms. Remember, Ohm's law says V equals to IR. We are looking for the current I. If we make a subject of formula by dividing both sides by R, we have that I equals V over R. The V is the voltage and it is 9 divided by 6, the resistance we've just calculated for. 9 divided by 6 gives us 1.5 ampere. So when the key is open, the current flowing in the circuit is 1.5 ampere. That is for the A part. Now let's look at the B part when the key is closed. When we close this key, what happens? It means there is now a continuous path for current to flow. So this current I flows, get to this point, it splits. Part of the current goes through this 4 ohms, while the remaining part continues through this closed key, through this 8 ohm resistor. Because the current coming here splits between two resistors, it means these two resistors are in parallel. Parallel resistors are resistors that allows current to flow individually through them, different current to flow through them at the same time. So the current gets here, splits. Whenever there is a split in current, those two circuits or those two parts of the circuit that the current flows after the split are already in parallel. So 4 ohms is in parallel with 8 ohms. And again, the current recombines here, and the same current that left this circuit continues and flow through this 2 ohms resistor. So technically, 8 and 4 are in parallel, and the parallel combination is in series with this 2 ohms resistor. So for the B part, when the key is closed, 8 ohm parallel to 4 ohms and in series with 2 ohms. When two resistors are in parallel, this is how you solve it. You multiply them, 8 times 4, and you divide the product by the sum, 8 plus 4. This part in bracket resolves this parallel combination, plus 2 because they are series. Because the parallel combination is in series with the 2 ohms resistor. 8 times 4 divided by 8 plus 12, 8 plus 4 gives us 32. divided by 12 plus 2. 32 divided by 12 gives us 2.67. And when you add 2 to it, the resistance becomes 4.67 ohms. So the resistance of the entire circuit when the key is closed is 4.67 ohms. Let's go to the next page. So when the key is closed, we've got the resistance as 4.67 ohms. To obtain the current, we know that the current is equal to voltage divided by the resistance. The voltage is 9, the resistance is 4.67. If you do this division, you find out that the current now flowing through the circuit is 1.93 ampere. So these are the two cases we've considered. The first one is 1.5 ampere when the key is open, and the second one is 1.93 ampere when the key is closed. Very simple, straightforward, and interesting. If you understood what we've done, then try this simple one. This is similar to this circuit. The only difference is that I have moved the key from this point to this point. So we now have the key here. And the question is asking, what is the current I flowing in the circuit when the key is open? When this key is open, what is the current flowing? Please put your answer in the comment section and I'll be there waiting for you. Thank you for watching this very interesting video and keep supporting Knowledge Base. See you in our next video.